ආයුබෝවන් this YouTube lecture series mainly considered about design of reinforced concrete structures. As we all know, both civil engineering students and the professionals who are in the civil engineering field that knowing about designing part of reinforced concrete is very important. We are using various standards for design reinforced concrete structures. BS8110, which we are using for a period of time. Now it is not in use. Basically, it is not going to upgraded, so it's in obsolete condition. So instead of that, Eurocodes has been introduced. Now, basically, this Eurocode 2 or EC2 is used for reinforced concrete designs. Now, in this series, mainly aim at discussing the points that comparing BS8110 and its changes in Eurocodes and its relevant national annexures. So therefore, subscribe this channel. You can get any notifications in time to come for remaining videos. Basically, when it comes to concrete structures, we can divide it into two parts. One is reinforced concrete structures. Basically, they are in situ, and the pre-stressed concrete structures, pre-tension or post-tension. Now, both these types, there are basically three main categories of structures: buildings, bridges, liquid retaining and containing structures. Normally, we call them as water retaining structures. Now, in this lecture series, we are mainly concerned on reinforced concrete buildings. Now, this division is very important because when you are selecting particular standards, its parts and particular clauses, we should be very keen on what type of structure we are going to design. Now, today's lecture, this session mainly aim at structural analysis part prior to design. Now, structural analysis we should have understanding of structural analysis part of a structure before we are doing the designs. Now, this analysis will not change according to the code, but it is some principles that structural analysis based on. Now, what is structural analysis in reinforced concrete building? Now, as we know, if we take a concrete structure or concrete building, there are various types of external loads acting on it. Normally, there are mainly two types: gravity loads, that is whatever we called now in Eurocode, these are called as actions, but normally we know there are gravity loads, and other thing is lateral loads or horizontal loads. Now, when these external loads acting on these structural members like beams, slabs or columns, it deform that elements will deform, and in the same time it creates some stressors within these structural elements. They may be bending stresses, shear stresses, torsional or twisting stresses. Now, structural designs, we are aimed to design for these elements according to these internal stresses. Now, as we see that concrete structure is a 3D structure. Now, if we know these external loads, now it is very difficult to analyze a 3D structure manually, right? For that purpose, you need computer programs, SAP, ETABS or whatever, computer softwares. But other than that, what happens when it comes to manual calculations, we can simplify these structures so that we can perform manual calculations. Now, for this purpose, basically slabs are considered as continuous members supported by the beams or structural walls. So now when we idealize the slab as a continuous beam, we can analyze these slabs. So in the same time, columns and beams, we have to consider them as a series of rigid plane frames. Now these are 2D frames. Now even in these 2D frames, we can subdivide them again into another simple structures. Now the mostly we very commonly what we are doing is we select particular beam in a particular floor level and its connecting columns. At the same time, there are some other ways. Now you can consider only the beam and its connecting columns, only the column and its connecting parts. So now normally what we are doing is we take a beam in a particular floor level, right? Then now when we take this structure, now these frames, there are two types. One is brace frames. Now brace frames are supporting only vertical loads. Now as earlier we said, these structures, they are supporting vertical loads and lateral loads. But when it comes to brace frames, they are supporting only vertical loads because there are some other strong element like shear walls and other structures to resist the lateral loads. Now when it comes to brace frames, for the analysis part, we know that if it is a statically determinate structure, like in the example, we can normally draw the shear force and bending moment diagrams. So we can calculate the shear stresses and bending stresses which are created within the structural elements. Other one is sometimes these elements, these subdivisions are not statically determined. They are statically indeterminate structures. So in that case, we have to use moment distribution method to manually calculate these shear force and bending moment within the structure. Now, in case of unbraced frames, we know that they have to resist lateral loads also. So therefore, what we are doing is, now we have to analyze this manual. To analyze this, there is some method called cantilever method. Using that, we can analyze this 2D frame for lateral loads. In this case, first we have to do the gravity loads or vertical load analysis as shown in the described in the earlier case, that is statically determinate structures, and then do this lateral load analysis part also. So this will, then we have to combine both together to get us complete structural analysis. Now this will solve total structural analysis manually, but these are valid only for simple regular low-rise structures. So in the same time, we know that there are some other requirements mentioned in the codes. So these are normally called as load patterns. Now we have to consider load patterns of each beam that we are analyzing and finally get the resulting shear force and bending moment diagrams and draw the envelopes for them and take maximum, minimum, and those important parameters from these diagrams. So basically, now this will cover basic aspects of manual calculation of manual structural analysis part of concrete design structure. So now for this is the end of first part of this series. So from next lecture onward, we will start the design part, design aspects according of the reinforced concrete design. So thank you. And in the same time, if you think this is important, so you can subscribe this channel. Thank you.